Good afternoon, sir. Myself, Mohammad Asif from CSC D section, and my today's CAA assignment 2 topic is implementation of stack using array with example. Let's move on another slide, sir. Here, this is the entire outline presentation. Introduction to stack, characteristics of stack, operations in stack, array presentation of stack, push function and pop function, display function, peek function, and conclusion. Let's move on another slide, sir. Here, this is the first slide of introduction to stack. Stack is an abstract data type with a bounded predefined capacity, which means it can store the element of a limited size. A stack is a linear data structure that follows LIFO. It means last in first row principle. The last element added to the stack is the first out to be removed. That means the element which we add last that was removed by first. Stack are commonly used in programming for function calls, expression evaluations, and backtracking. Here there is some real life examples of stack in our daily life. Stack of books, plates, and CDs, like this. This is the real time examples of stack. Let's move on another slide, sir. Here, characteristics of stack. Stack can be implemented using arrays or linked list. They support two primary operations. That is, stack mainly supports two primary operations. That is push and pop. Push means to add element. Pop means to remove element from the stack. A, a stack is also often includes a peek operation, which allows for viewing the top element without removing it. Here the picture here the picture explains the detail about push, pop, peek functions. Here uh, here see this push. Here we add 3. Adding means push, nothing but. Here pop means remove. Here we remove 3. So the remaining elements is 2, 1. Here in the first stack, the top element is 3. In the next stack we remove first element, that means 3 we removed means nothing but pop. So here the top element is 2, like this. Here is full means the stack reaches maximum size. It means is full. Is empty means there is no elements in the stack, that is empty. Here LIFO means last in first out. FILO means first in last out. Here stack operations. Stack mainly contain 3 operations, that is push, pop, peek. Push means adding element, pop means removing element, peek means first element, that is top element, nothing but peek. Implementation of stacks. There are mainly 2 types of implementation of stacks, that is by using arrays and using single linked list. By using linked list. Here today my topic is array representation of array. So I will discuss array representation of array. An array can be used to present a stack with a fixed size. The top of the stack is tracked using an variable. When a stack is empty, the top index is typically set to -1. A stack data structure can be implemented using one-dimensional array, but stack implemented using arrays stores only a fixed number of data values. Here this picture clearly represents the array representation of stacks. Here we add 50, 40, 30, 20, 10 in the stack. Here 50 means 50 index is 1. We add 50 first, so its index is 1. Mainly arrays indexes starts from 0. So here 50 is the first element. So 50 element index is 0. Next 40 index is 1. Next 30 index is 2. Next 20 index is 3. Like this. Inserting value into the push is nothing but inserting value into the stack is nothing but push function. In a stack, push function is used to insert an element into a stack at top position. The following steps are used to push an element on the stack. Here, step 1. Check whether the stack is full or empty. Here, any function we use in the stack, first we want to check whether the stack is empty or full. Here we use this code. Top is equals to size minus 1. This is the code. Next, step 2. If it is full, then display stack is overflow. Uh, Otherwise, if it is not full, then increment the value by 1. That means code top less place increment function and set stack of top to value, like stack of top is equals to value. Here this picture may clearly represents the push function. Here the stack contain 1 2 3 4. Again we add 10. Adding means nothing but push. Here this is the program. First we want to write void push int element and int element. First we want to declare whether the stack is empty or full. So here we use if top is equals to size minus 1, where stack is overflow. Then otherwise print f stack, if stack is overflow, else printf enter element to push, scanf modulo d ampersand element top plus plus incrementation stack of top is equals to element. This is the code of the push function in stack. Next we will continue stack pop operation. Pop function. In a stack, pop function is used to delete an element from the stack at the top position. The following steps are used to pop an element from a stack. Here, step 1. Check the whether is stack is empty or not. Here we use top is equals to minus 1. If stack is empty, then display stack is underflow. Terminate the function. If stack is not empty, delete stack of top and decrement the top value by 1 of top minus minus. Here in the stack there is 4 elements. We popped 1 element. So here next stack contains only 3 elements. 1 2 3. Here this is the code. Void of pop. Here we use where the stack is empty or not. So we use this function if top is equals to minus 1 if condition. Next here printf stack is underflow, else printf /n deleted element is modulo d stack of top. Here top is equals to top minus 1. This is the entire code of pop function in stack. Here next display function. The following steps to display the elements of a stack is step 1. Check the whether stack is empty or not. In every function we must use where the stack is empty or not. First this is must and should. Top is equals to minus 1. This is the condition. If the stack is empty, then display stack is underflow and terminate the function. If stack is not empty, then define a variable I and initialize with top. Display stack of I value and decrement I value by I 1 of my I minus minus. Stack for step 4. Repeat above step until I value becomes 0. Here this is the entire code of the display function. Void of traverse means nothing but display. Here we want to initialize I. Here int I. If here this is the condition where the stack is empty or not. If top is equals to minus 1, printf stack is underflow, else for I is equals to top I greater than is equals to 0, I minus minus, printf modulo d stack of I. This is the entire code of the display function. Here next a peek function. The peek function prints the element at the top of the stack without modifying the stack. The algorithm for peek is follows. Here step 1. If top is equals to minus 1, then printf stack is underflow and stop, else go to step 2. Here step 2 is set element is equals to stack of top. Element is the top element of the stack. Step 3. Print element as peek value. Here peek value is nothing but the top of the value. Top of the stack is called a peek. Here in this picture there is a 10, 20, 30, 40, 50. These are the stack elements. Here 50 is the top element. Top elements is nothing but peek. Here this is the entire code of the peak function. Int peak, if top is equals to -1, this is the condition for where stock is empty or not. Else stock of else return stock of top. Conclusion: implementation of stack using an array is straightforward in C. Understanding the operations and their complexities is the crucial for effective use. Stack are fundamental structures that helps in various programming scenarios. Thank you, sir. This presentation was presented by Muhammad Asif from CSCD section, Srinivasa Ramanujan Institute of Technology, Autonomous. Thank you, sir.